In this video we're going to look at Newton's third law. We're going to briefly recap Newton's first law, then Newton's second law, then we'll go into Newton's third law, which we'll look at both qualitatively and quantitatively, and then we'll look at a couple of examples showing the numeracy involved in Newton's third law. Firstly, Newton's first law, or the law of inertia, which states that an object at rest will stay at rest unless acted on by an unbalanced force, and an object in motion will stay in motion unless acted on by an unbalanced force. So, as we've discussed, if it's standing still, it will stay standing still, and if it's moving, it will continue moving unless acted on by a force. Newton's second law states that an object will accelerate if an unbalanced force is applied to it, and the acceleration will be proportional to the size of the force and the mass of the object. Okay, so the greater the force, the faster the acceleration, or the greater the mass, the more force that is required to accelerate an object. And remembering that we can state this in a formula of F equals ma. What we're going to go on with now is Newton's third law, and this is a law that is often misquoted, but what it states is that for every force there is a force of the same size working in the opposite direction, and we call this the action force and the reaction force. And so they're the same size in the opposite direction. So here in this picture you've got the man leaning, and he's putting his force from leaning to the right hand side on the girl's hands, and the girl's putting force to the left hand side. Now both of these people will experience the same force pushing through their hands, and therefore they will be stationary. So if we wanted to put this into an equation, we could say that force 1 is equal to force 2, where force 1 is the action force and force 2 is the reaction force. Or, as we know from Newton's second law, because F equals ma, we can say that the mass and acceleration of the first object is going to be equal and in the opposite direction to the mass and acceleration of the second object. What we'll do now is go through a couple of examples of where this occurs. Now, a good example of an action-reaction pair is when firing a weapon. You get the bullet being projected out of the barrel, as well as you feel some recoil back into your shoulder. So that's your two forces. Okay, so in this example, we've got a Marine firing an M4A1, which weighs 2.7 kilos, and a bullet weighing 3.5 grams being accelerated at 500,000 meters per second out of the barrel. And we want to find the acceleration of the weapon into the shoulder, or the recoil. Now what we do is first find out what we know. So we know that the mass of the first object is the bullet, 3.5 grams, or if we were to convert that to kilograms, it would be 0.0035 kilograms. And we know that the acceleration is 500,000 meters per second, and the mass of the object 2, the M4A1, is 2.7 kilos, and we're trying to find the acceleration, or the recoil. Okay. So once we've worked out our known values, we can use the formula M1A1 equals M2A2, and substituting those numbers in, we see that 0.0035 times 500,000 equals 2.7 times the acceleration of the weapon, and a little bit of maths, and we can find that the acceleration there is 64.8 meters per second into the Marine's shoulder. Now in this second example, we've got the Marine's friend who's firing an M16A4. Now the projectile that's used here is the same. The difference is going to be the mass of the weapon. So the M16A4 weighs 4 kilos. So again, we work out the things that we know. So again, the mass of the bullet is 0.0035. The acceleration is 500,000 meters per second. However, here, mass 2 will be 4 kilograms. And again, we're looking for the acceleration. So we use our formula, M1A1 equals M2A2, and substituting those numbers in, 0.0035 times 500,000 equals 4.0 times A We simplify and divide by 4, and we find that the acceleration is 43.8 meters per second per second. So what we can see from these two examples is that increasing the mass of one of the objects will decrease the amount of acceleration that that object feels. This is why when firing a heavier weapon, you get less recoil or less acceleration into your shoulder, and while firing a weapon that has a larger projectile, like a shotgun for example, you have more recoil into your shoulder. In this video, we've looked at Newton's first law, being the law of inertia, that an object that is still will continue to be still, and an object that is moving will continue to move. We've looked at Newton's second law, that shows that acceleration is proportional to the force and the mass of the object. And we've looked at Newton's third law, stating that for every action force, there is an equal reaction force that occurs in the opposite direction. We then looked at a couple of examples of action-reaction pairs, and we looked at recoil when firing weapons, and we saw that as you increase the mass of the rifle, you decrease the amount of acceleration or the recoil, and I also mentioned that if you increase the mass of the projectile, you will increase the amount of recoil